Thank you so much for that introduction. And that is actually a fascinating thing to hear that people have been responding. Fortran is not dead, yay, because as I was presenting or preparing for this presentation, I was wondering if I should even mention the idea that some people have out there that Fortran is dead. It's a conversation that I have a lot with my group lead at Berkeley Lab, Damien Roussan, who is the co-author. He helped me a lot with this presentation, so I've credited him on this title slide. But just as an aside, Damien and I have frequent conversations about whether we even want to highlight the fact that that is a prominent idea out there, that Fortran is dead. We're obviously trying to impress upon people the idea that Fortran is not dead. So, but it is definitely an idea out there. So hopefully this presentation will show you today, or convince those who might be skeptic, and hopefully some audience members are already on board with the idea that Fortran is not dead and perhaps are active joyful users of Fortran. But yes, today we'll be exploring a lot about that language, which does incite a lot of different opinions. So yes, thank you for that wonderful introduction. My name is Kate Rasmussen, and I am indeed a software engineer at Lawrence Berkeley National Laboratory. I work on a lot of different projects related to Fortran in some way, as was mentioned in my introduction. And today I will be talking about Fortran 2023. Sorry, let me just start my timer. But yes, today I will be talking about Fortran 2023 for you, features and tools. And as I already have mentioned briefly, Damien Roussan has helped with this presentation, so I'd like to say a big thank you to him. As I said, he's my group lead at Berkeley Lab, and I consider him a Fortran guru. So he is definitely somebody that I knew I would want to help revise my slides with me. And in preparing for the presentation, he gave me some feedback. Damien just waved to the camera. But in preparing for this presentation, he gave me some really helpful feedback that improved it overall. And there's also one particular example that he helped with immensely. So we'll encounter that wonderful example later. So thank you to Damien. Today, the presentation will be split into three main sections. First, we will explore some useful features of Fortran. Then we will explore some tools that can aid in Fortran development. And then we will finish with an exploration of Fortran developer communities. So jumping in first, we have our features. So one thing that I wanted to discuss first is some terminology. Throughout this presentation and throughout other presentations I've given in the past, or presentations that other team members at Berkeley Lab have given about Fortran, we use a lot of different terms, and sometimes we use them the same term to mean different things. Sometimes we use different terms to mean the same thing. It's sort of a evolving thing with some of these terms that we use. So I want to discuss that a little bit first. One term that we hear a lot and that I've used a lot myself in presentations, including at a BOF that I host, that I've organized at SC for the last 2 years, is modern Fortran. So that term is in the title of the BOF that I've organized. And so what does modern Fortran even mean? Oftentimes people associate Fortran with legacy code, of course. It's been a programming language that has helped aid science for many, many decades, which we love. But people sometimes associate it with just the past and not so much the present. So the purpose of the BOF that has modern Fortran in its title is to explore support for and usage of features introduced into the language more recently. But the term modern Fortran can refer to a variety of different things. Sometimes I have used it to refer to specifically just the parallel features of Fortran. Sometimes it is used to refer to anything from more recent standards. But also, since Fortran 2023 is the most recent standard, you might hear Fortran 2023 to just refer to the features introduced in the last standard, or even just features introduced in the past couple standards. Since a lot of people, I think, have Fortran 90 in their mind, depending on what their experience with Fortran is, they might just view it as sort of a Fortran 90 type language. So Fortran 2023 might be used to impress upon people the idea that there's many standards that have occurred since that time. So just as a warning, all of those terms are used, but for the purpose of this presentation, I just wanted to introduce some features that highlight some of the features that are useful that have been introduced into Fortran in more recent standards. So here on this slide, I have listed some of those features, which include, but are certainly not limited to, do-concurrent, which provides loop-level parallelism. There are a number of features that provide the multi-image parallelism that Fortran has, which includes coarrays. There are related intrinsic functions to coarrays. There's also collective and atomic subroutines, teams, lock, events, and more. And then also polymorphism and C interoperability. So that's just sort of a highlight of various features that Fortran has provided more recently. And I really want to highlight that Fortran is a native parallel language, and it has been one since 2008. You don't have to use OpenMP or MPI in Fortran to achieve either loop level parallelism or multi-image parallelism. And Using the native parallel features of a language can come with certain benefits. They can include benefits such as being easier to write and even potentially faster to run. This can be because a well-designed compiler will likely be able to generate more sophisticated MPI than one could write on their own. If a compiler, for example, is using MPI under the hood to support coarrays in Fortran, or a compiler, in fact, might not even be using MPI at all on the hood. It could choose under the hood. It could choose to use another networking layer like GasNet, which could in fact benefit performance. So while mentioning the benefits of these features, I do have to mention a significant limitation of these features as well, which is compiler support. As shown here, there are 3 Fortran compilers that now support automatic offloading to GPUs for do-concurrent, which is great. But one will find more spotty support perhaps for coarrays and the other features that make up the multi-image parallelism in Fortran. But I did want to mention, while admitting that there is times compiler support issues for some of these features, I did want to mention, though, that my group at Berkeley Lab is doing what we can do to help that situation. And we have developed the parallel runtime interface for Fortran, which is a compiler agnostic and runtime library agnostic interface to support the parallel features of Fortran. And we are also developing Caffeine, a runtime library that implements that interface. So that is a perf interface. And with Caffeine, we are targeting LLVM Flang and LFortran to provide the support for parallelism for those 2 compilers. That is a goal of ours in the future. And there are links to both of those libraries on this slide. So next, I want to talk about features that I don't think get talked about as much in presentations when Fortran is highlighted, when the more recent features of Fortran are highlighted. And those are some intrinsic functions. And in fact, some of these functions are not necessarily that recent. Some of these intrinsic have been around for a while, but I don't think they get highlighted as much, which is why I am presenting them here. So there are a very, very large number of intrinsic functions and subroutines in the Fortran language. So it is, of course, not easy to keep track of all of them or to remember what is available. But for this presentation, I have chosen to point out the following 5 functions. First, we have findLoc, which returns the location of a specified value in an array with an optional mask argument. There is also pack, which packs data in an array of rank 1 after a mask is applied. There is the count intrinsic, which counts the number of values in an array that evaluate to true after a mask isn't applied. And then we have merge, which merges variables based on the logic of the mask argument. It essentially provides the functionality of the ternary operator in C++, if you're aware of that operator. We have index, which returns the position of a substring within a string. And note that many of the functions listed here have a mask argument. Sometimes they're required in the listed intrinsics. Sometimes they're optional. But just note that the logic used in a mask argument for these can be very helpful in providing a lot of great functionality. And another thing that I would like to highlight is that some of these intrinsics are very amenable to combination in expressions, and when combined can provide some really great functionality again. So you can find the full list of intrinsics in the Fortran standard, of course, but in this slide, all of those underlined bits are links with more information, sort of definition of the basic functions, and then some examples, and then also just a page with even more examples of intrinsics. But of course, it might be hard to sort of immediately understand how some of those might be useful just by me reading off their names and their basic description. So in order to illustrate how they can be useful, I have come up with this example, in fact. So here we're going to explore a use case where the usage of these functions that I have 3 of the functions that I listed on the past slide, we will find in this example and see how the usage of intrinsic function calls can greatly simplify and improve code. For this example, we are going to look at the source code that is needed for a functionality in Julienne. So now Julienne is a unit testing framework. We will actually be visiting Julienne again later in this presentation. But for this example, all you need to know is that it is in fact a unit testing framework. And one of the functionalities of Julienne is that when the user is calling the test suite, they can pass a flag that contains and then pass a string. So they can pass that flag to the test, to Julienne, that then it will only run the tests that have the string that the user passes in the description of the test themselves. So we will explore more of what that looks like here. So this screenshot shows 2 collections of tests in Julienne. One collection of tests an array of bin t objects, which you can see on the first couple of lines here. And the other collection of tests a format string. So the green boxes are around the subject string, which describes the collections of tests. And then the blue boxes here are around the test description strings, which describe each unit test within that collection of tests. So as I said, when a user passes the flag, Julienne will only run the tests associated with that are found in those strings that you can see on the screen. So the functionality that we need in Julienne to provide that to the user is that when the user passes that string, the program needs to search the subject string for that substring. And if it is found, run all of the tests in that particular collection of tests. If that string is not found in the subject string, it then needs to search the array of test description strings for that substring and then run only those tests where it is found. Here we have some 37 lines of code that achieves that functionality in Fortran. So the details of which are not important, so please don't worry about straining yourself to try and read this really quickly. The details of the implementation are not important, but the point is that there's a lot of logic here that we need to try and achieve the functionality that I've just described. And so here it is done in 37 lines of code. But what you will find by the end of this example is that all of that logic and functionality will still be available through many less lines of code. So let's begin. Here we have some highlighted code in green. So this highlighted code is searching the subject string for the substring and then setting a logical variable based on whether the string is found or not. So all of the code highlighted in green will be transformed with the usage of a single intrinsic function. Aha! And that function is the index intrinsic. So with just the use of the index intrinsic, we are able to replace all of those lines of code on the previous slide highlighted in green with just that one expression now highlighted in green. The index function will return a 0 if the substring is not found in the subject string, in which case the else case is then triggered, of course. And if the substring is found, then an index is returned, the value of which we don't actually care about. We just need a non-zero value to indicate that its presence, and then to enter the if case. So now that we have a 27 lines version of code here to achieve our functionality, I have highlighted 2 more lines of code. And so those 2 lines of code highlighted in blue will be transformed with the addition of another intrinsic call. So these 2 lines of code here are to count the number of matches where the substring is found in an element of array of test description strings. And that is needed for other logic to then do the other functionality that was described earlier. So we can see that with the addition of the count function, which I mentioned earlier, now those 2 lines of code are transferred into 1. So we only saved 1 line of code here, so it might not seem like that exciting. But what we did save is that we avoided having to do conditional logic in a loop, which can make optimization more challenging. So that in and of itself can be beneficial. And now that we have the 27-line version, we are going to introduce another intrinsic. And in fact, then we will be transforming all of that code now highlighted in purple. So that is a pretty significant amount of code that will be able to be transformed by just 1 intrinsic. And that's doing a lot of functionality, so I won't go into details about what it is, but it is doing a lot of the rest of the logic that I mentioned when I talked from a higher level about what is needed to be done. And so as you can see, all of that highlighted code now from that last slide just became 1 single line with the addition of 1 single intrinsic function, the pack function. And in fact, we just replaced the count function that we introduced. So that was sort of an intermediary step in this example to show that it is useful. But in the end, the pack function is allowing us to do a lot of things that we need to do for this functionality. And we no longer even need the count function. So the pack function, as I mentioned earlier, packs data into an array based on the logic from the mask argument. So in the lines above 68, so 68 is the highlighted line in purple. On the lines above line 68, there's a scalar logical substring in subject and a logical array substring in description, which the value of which is set for both of those variables. The values are set based on whether the substring, of course, is found in the subject or whether the substring is found in the array of test descriptions. And then those logical variables are passed to the mask argument of pack. So as such, the result of line 68 is that the test descriptions array will be unchanged if substring is in subject is true, and then all of the tests will be run, which is the desired functionality. And that is true because each element in the array that is constructed based on the expression substring in subject or substring in description will be true. Now, if substring in subject is false, then the result of line 68 is that the test array description, the test descriptions array will only have the tests where the substring was found, which then allows line 70 to run only those tests. So just as a note, the expression for the mask argument, substring and subject or substring and description, works because in Fortran, a scalar is conformable with an array, as the first logical is a scalar and the second logical in that expression is an array. And since, as I said, scalars in Fortran are conformable with arrays, Fortran is able to construct an array on the fly with the logical comparison of those two values. So just as a reminder, I think that this is one of my favorite parts, is that all of this code replaced with just one line with the pack function being introduced. So what's next? We, in fact, are done adding intrinsic function calls, but we can continue to reduce the code even more by doing something that I mentioned is helpful when I introduce the idea of some of these intrinsics, which is by combining them. So how many lines will remain once we combine these intrinsics? Let's find out. Da-da, drum roll. We only have 2 lines left. So you might need a magnifying glass to read this 2-liner, and you will probably need to set a compiler flag to accept a line with more than 130 characters, because this line is most certainly, one of those lines is most certainly longer than 132 characters. But we do, in fact, just have 2 lines of executable statements where we started with 37. So just those 2 lines achieves all of that functionality, or all of that logic that we needed to use 37 lines of code where we started with. So here, for the sake of all of our eyes and brains, I have expanded those 2 lines. I've added some line continuations to make it more readable. And in fact, in the source code where this example was taken from, we do not try to fit all of that on one line. We, of course, have the line continuations for both readability purposes and not needing to pass that special compiler flag. But again, it is still 2 lines of executable code. So as you can see, by using the index call inside of the expression passed to the mask argument of pack, you are able to reduce the lines of code and reduce the logic needed to achieve the desired functionality. So the lessening of that logic and lines of code can help reduce the likelihood of bugs being introduced while in development and maintenance of such code. And the usage of intrinsics may sometimes, in fact, open up opportunities to the compiler for optimization, because these intrinsics are letting the compiler know very specific things about what you are trying to do. And whereas if you're doing them all on your own, the compiler might not recognize things that it might be able to optimize away. Now, this slide is just sort of a brief review of the concepts that were used in this example to help achieve so much in so little amount of code. So as seen here, we have the 3 intrinsic functions that were utilized in this example, one of which we didn't end up needing in the end. But we also took advantage of automatic allocation of arrays in Fortran and also automatic reallocation of arrays in Fortran. And we also have some elemental type-bound procedures. So within that example, there were a variety of drive types that were being used. And so those drive types have type-bound procedures, which are elemental and also pure. So those are some more Fortran functionality that we're taking advantage of. And this is the point in my presentation where I would like to again note my gratitude for Damien Roussan, my group lead, for help with this. Because while I was developing this presentation, I knew I wanted a really great salient example of how the combination, not just the usage of some of these intrinsic functions, but how the combination of multiple intrinsic functions can provide a lot of functionality. And from working with him, I knew that that there would be code that he had written himself that would be like really great salient examples of that. And so I, of course, discussed this with him. And the 2 lines of code that we saw at the end of that example on the last slide is actually the code that he started off with, that he originally wrote as part of the Julienne testing framework. So while he helped me identify this example of intrinsic functions, he then got excited and helped also reverse engineer those 2 lines and then came up with the 37 lines of code that we started with, which didn't have calls to the particular intrinsic functions that we saw. It did have calls to intrinsic functions such as size and len, but not the sort of the ones that we hear talked about less, perhaps. So thank you so much to Damien again for helping prepare this example, because I think it highlights a lot of really useful features in Fortran. So now that we have touched upon features, I wanted to speak some about tools that are available within the Fortran ecosystem, some of which you may have heard before, some of which you might not have, but hopefully there will be some things here that are useful. So first, we have FPM. FPM stands for Fortran Package Manager, and it is, in fact, both a package manager and a build system. And we will be seeing a small example of FPM in action soon. But for more information about FPM, please follow the link in this slide. But the little spiel that I would like to give about Fortran or FPM myself is that it is in fact written in Fortran, which is quite exciting because then the users, if you're using a build system to build a Fortran project, then you assumedly are a Fortran user in that sense. And so what makes FPM exciting is that the people who are likely to use the product itself are also people who can contribute to it because it is written in the language of the users. So it is written in Fortran. It is maintained by the Fortran developer community. And one other benefit that I find wonderful about FPM is that it automatically detects file dependencies. So that simplifies the build system files that you have for FPM compared to a lot of other build systems out there that you might be more familiar with. Another thing about FPM is that it supports both Fortran and C source code. As I mentioned earlier, Fortran has C interoperability features. So of course it's important for a build system that to build Fortran projects to also have the ability to build C code, and FPM does have that ability. FPM does also potentially have the ability to build C++ source code if you have C++ source code in your project, but that support is perhaps more spotty. I have not myself had the need to try and build a project with FPM that included C++, but I've heard from colleagues that there are circumstances where there might be some issues with that, but also circumstances where there might not be. But it very much does have support for both Fortran and C source code. Another thing to highlight is that FPM itself is very easy to install. It is available to download to install through various package managers that you might have, but also if you use Fortran 13 or have that compiler installed, you can also compile a single file version of FPM, of the entire FPM source code. And that's just by compiling that one single source file, then you are able to install the package manager. So that's very useful. For FPM to be able to fit all of their source code into one file, they take advantage of some very specific sort of extensions. So that's why not all compilers you can do this with, but with Fortran 13, I can speak to that. That is possible. So unit testing. While unit testing might not be the flashiest or the most exciting topic, I do think it is very important. Unit tests can, of course, help improve software projects because with good code coverage with your tests, they can catch bugs, they can prevent code regression, and they can even serve sort of as documentation. They can be self-documenting. So the example from the last section, we did see a brief look at Julienne, which we're going to discuss more now. So Julienne is, in fact, a lightweight unit testing framework that is developed at Berkeley Lab. The test output can be read as a specification, and we'll see some more examples of what that test output looks like. And the test output itself can provide some very useful diagnostic information as well when tests fail. Assert is another software package developed at Berkeley Lab, and that is a utility that helps verify constraints and can be added to Julienne tests to come up with some really great unit tests. So Assert allows for useful diagnostic output from pure procedures, which is very helpful. And for more information about either of those packages, please do follow those links. But we will explore Julienne a bit here. So this slide is just to indicate in textual form, some things that will be seen on the next slide in video form. So I'm going to skip through. Before I press play, I will say that this is a short recording of an example of what it might look like if you are trying to start to use Julienne from scratch. If you've not used it before, this will show some examples of how you can get started. And in this example, you will also see some basics of FPM. So one feature of FPM is the command fpm new, which sets up a directory which has all of the sort of Git files that you might need to set up a Git repository on some remote server. And then it also just has the basics of an FPM project that are basically just, examples that then you can fill in with your own code specific to your project. Okay, so here I'm typing fpm new example project, and you can see that it has set up those basics that I mentioned. Here is just an overview of what is set up. So we have a README file. Of course, it does not contain any particularly useful information, but we have a README file set up that you can then go in and edit. We have a basic main program and app. We have a source directory with just one file. And then we have a test directory with just one program, and we have an FPM TOML file. So an FPM TOML file is also referred to as an FPM manifest, and that is basically just the build system file where you go in and set various things to then help tell FPM how to build your code and what is necessary to build your code. So here I'm just catting the test just to show that it is It's just a print statement. It doesn't do anything, but it is there just to show you where your tests will go. And we will in fact be replacing that test with the basic Julienne example test. And we can see what that will look like. But first, in order to use Julienne, I need to set it as a dependency. So here is an example of the FPM TOML file that is automatically set when you use FPM new. And so these are the things that you would update for your particular project's needs. It can fill in the information that you have on your Git config, as it has done with me here. So here I'm going to show how I can add Julienne as a dependency. So I just add those 2 lines. And now Julienne, when I build, Julienne will build alongside my software project here, the basic software project. And one thing that is, so I just deleted a bunch of lines from this file to show you that the default values for those things that I deleted are often enough for an FPM project for your source code. Of course, there are plenty of projects out there that use FPM that do need to set specific things for those flags that I deleted. If you want to learn more about those things, you can read the FPM documentation. But briefly, there are, things about tests, about module naming, about whether you want to install a library or not, about implicit typing versus explicit typing, etc., things like that, fixed form versus free form, things like that. But oftentimes, those values are not even required in the FPM manifest, and you can just go with the default values potentially. And so I've deleted them to illustrate that here, and that what we have at the end, this is a build system file, essentially, for FPM. There's not a lot in there, but it provides a lot of wonderful functionality even so. So I wanted to highlight that. So now that we have that saved and we have the Julienne dependency available in our FPM manifest file, all I have to do now is do FPM build, and then now it will build the project. And of course, it is not much of a project. There are only a couple of files, but it automatically detects which files need to be built first. And again, the simplicity of which files need to be built here is not particularly impressive, but you can have hundreds and hundreds of source code files, and you don't have to tell FPM anything about the order of the dependencies between those files, and therefore the order in which they need to be built. FPM is able to detect all of that on its own, which reduces a lot of burden on the developers from needing to maintain specific lists with ordering that matters. So that is one huge benefit of FPM. So my project has been built, and now by running FPM test, I'm running the test suite. And so, of course, that test doesn't do anything, right? It just prints. It's just a program that prints the statement, put some tests in here. So now I'm going to copy from Julienne. Let me get it a little bit. Okay, yeah. So now you can see that line above the place where the bar comes up when I press pause. But so if you have Julienne cloned locally, then you are able to just copy a directory, all of the files from a directory in example test suite. And so here I have copied all of those files into the test directory, and that is what will help us get started with using Julienne to write some unit tests. So here I copied all of those files into the same directory. And so here I'm showing the content of specimen_m.f90, which is a module, which is in fact, for this example's purposes, it would be considered source code. So as such, I'm going to move that source code into the source directory. But then what is left now is just the files in the test directory that are needed for Julienne. So now all I have to do is do FPM test. It will rebuild things. So it is building the new file, the new source code file, specimen_m, and it is also going to build the files needed to build Julienne, the dependency. So that is what it is doing here. It is building all of those, and then it ran the test. So here, I mentioned earlier that unit tests can be documentation sometimes. So here we have the output from Julienne, which states a specimen T object fails on the type-bound function 0, producing a result of 0. So as you can see, that kind of documents a little bit about the function 0. It says a little bit about what it is. It is a type-bound function. It is also showing that 0 is a type-bound function of the specimen T object. So if you construct the Julienne test output in a certain way, then it can be really helpful just when you run a full test suite. If you have, say 10 collections of tests on that test 10 different drive type objects, for example. And then, each one might have 10 unit tests within that. And then you have 100 tests. You can then see in the list of output a variety of the things in your source code that is being tested. And in that sense, it can be a type of documentation. And the next thing to note, of course, is that we have a test failure. Oh no, whatever shall we do? So this is, of course, on purpose, but you can see here what it looks like when a Julienne test fails. And the diagnostic output is then provided, which I will be highlighting soon in this video. So we have 0 of 1 test pass, and we have that diagnostic string, which shows that we expect. So that's, again, the output about the test description. And then we have the diagnostic string where we can see that we expected the value 0, and we instead got the actual value of 1, which is, of course, why our test fails. So next, I will go into the implementation of the 0 function to try and fix this test failure. So here we have 0. And of course, you can see, in fact, we are providing the value 1, which is incorrect. So all I'm going to do is to provide the correct value. Just to make things all work out a little bit better, more clear, I'm going to then, of course, change the name of the return the result of this function to correct value to indicate that it has been fixed now. And all I have to do then is go back and run the command fpm test again. It rebuilds what it needs to rebuild, and then it runs that the test suite, which at the moment is just that one test. And now we have a test. We have the test passing. So that was an example of the basics of how you can get started with copying the example from Julienne. But if you wanted to add your own test, I've also just this little example to show you how you might be able to do that, to start writing your own unit tests for Julienne. So here we have a short example of that. So imagine you want to write a unit test for a function called increment that is part of the same module that contained the 0 function that we just saw. So on the slide, I have the code snippet where it shows what that test could look like. Increment is also a very basic function, the purpose of which you can imagine. But I want to point out that the diagnostic string, which I have highlighted here in green, in this example is very similar to the string that we saw in the last example. So we have an expected value, and then we have the actual value. And so if the test fails, then you will get that diagnostic string with the correct input. But one thing I did want to point out is that diagnostic string, there's a lot of flexibility in how you construct it. So for your particular unit test, you can write whatever you would like and provide whatever values you would like to be able to give the useful information that will be useful diagnostic information for that particular unit test. This function, that check increment function that I've added here, would be this is contained in the same module that contains the collection of tests for the specimen module. So we have a specimen module in the source code, and then we have a test specimen module, a test specimen in the test code. And so as increment, I added the function increment to the specimen module. Then I'm also adding this function check increment to the same file that contains the module for all of the collection of tests, a collection of unit tests that are provided to, or that are designed to test that specimen module. So when you write a new unit test in a collection of unit tests, the thing that you then need to do, you first need to write that new unit test, which is in the function that I just showed on the last slide. And then in order to make sure that you get that unit test called, you need to update the results function, which is a function in each of the collections of unit tests. You have a results function, which calls all of the unit tests in that collection. So here in green highlighted code, I just have shown the things that I needed to add to then trigger the invocation of the new unit test increment that I showed. So there's not a lot of things that you need to update, but you just need to have a function pointer and then add it to the array of test description and have a test description string. So that is there. And then the last thing that you would need to do if you wrote a new collection of tests in Julienne, you would need to add that to the main program, which calls all of those collections of tests. But because I added that new unit test to a already extant collection of tests, I didn't need to change the main test program at all. But I've highlighted in green the two things that you would need to add a similar version of if you did have a new module with a new collections of tests. So that hopefully gives you an overview of how you might start to use Julienne if you would like to try it out for yourself. There's, of course, more information on the repository, and you can always contact us at Berkeley Lab if you have any additional questions about Julienne. So, other things that we can do, other things out there available for people working in the Fortran ecosystem. So, you might have thought that you could get away by attending a presentation with no discussions of AI, but false. Today, we will discuss very briefly. And that is because, of course, we all know that machine learning and AI is and will continue to have an impact on how we do HPC. And so, I just wanted to mention that if you want to do deep learning yourself for any scientific needs that you might have, you don't have to turn to PyTorch automatically. I did want to mention that there are deep learning libraries that are written in Fortran, and one example we have here is FIATS. And FIATS is the Functional Inference and Training for Surrogates, which is a deep learning library written in Fortran. Alternate name, which still matches the acronym, is Fortran Inference and Training for Science. So this library is developed at Berkeley Lab, and Damien Roussan is the lead author. So if you have any additional questions about FIATS, please do feel free to contact him. And I will talk a little bit about the end of this presentation about how you can contact us at Berkeley Lab. But FIATS provides training and deployment of neural network surrogate models for computational science. So yes, don't have time to talk a lot about that here today in this presentation, but I just want to point out that we do have these things available in Fortran that you might not have been aware of. So I wanted to end this tool section with kind of a grab bag of some discussion of additional Fortran tools that you may or may not be aware of and that could potentially be useful for you in your work. So the first one here is Cody. So Cody is a static analysis tool for Fortran and C++. It can help you verify code correctness, and also it can help automate some modernization of the code. More information about Cody can, again, of course, be found in the link on the slide. There are a lot of links in this presentation, so I do hope that if there's something that you find useful, please do download the slides that will be provided later. But yes, you can find out more about Cody here. Cody also has a YouTube channel where they have some tutorials recorded that show a little bit of the functionality for Fortran. And then Cody also did a training at NERSC, which is the HPC Center at Berkeley Lab. That training happened last year, and that was recorded and can also be found in this link on YouTube. I also wanted to mention Fortran Linter. Fortran Linter is a more lightweight tool than Cody, but it can also perform some helpful analysis of your code. I was working on a project recently to modernize some legacy source code, and there were some tasks that my colleague was doing related to that project where Fortran Linter was very useful to him. So I've not personally used Fortran Linter. I have myself used some other tools to automate modernization of Fortran source code, but the one that I have the most experience with in the past couple of years is unfortunately not under active development anymore. So I have chosen not to mention that here, but rather mention things that are under active development, and that could be potentially useful going forward. Another thing that I wanted to mention is ROGFF. ROGFF stands for the return of JSON for Fortran. So if you use JSON file formats for input or output to your project, please do know that there is this utility to help support the usage of the JSON file formats in Fortran source code. There is also linked here the isovarying string repository, which is an implementation of the isovarying string module that was proposed for the ISO standard, but did not make it to the ISO standard. But if you potentially have usage for the functionality of what that proposal was of isovarying string, then you can find that here. Grab bag continued. I wanted to just briefly mention Forward. So Forward is Fortran documentations tool. Forward then kind of stands for Fortran documentation. It is an automatic documentation generator for Fortran projects, and you can build the documentation locally, and then you will be provided with HTML files that have all of that documentation. But you can also deploy documentation in something like a GitHub Actions in CI, and then be available on the web publicly. Here I have linked of an example Fortran documentation. I won't go through that link today for time's sake, but please do feel free to check it out if you would like to. And I just also want to mention, I'm no fan myself of fixed form source code, but there is a lot of fixed form source code out there. And, this for legacy code that has been around for a long time, there are very good reasons why fixed form source code is out there. But if you are in fact considering converting fixed form code to free form code, I just want to point out that there are loads of tools out there that can help you with that. And I'm ending my grab bag to link to a grab bag essentially. So while I was preparing this presentation, I found that there is a repository on GitHub called Fortran Tools from the user Belyovsky, and it is basically just a README with a link to a huge number of tools. So I don't know half of the tools in this list, but it is something that I discovered and that I will be checking out more myself in case I find something that I wasn't unaware of that can be useful for me in my work. So I wanted to link to it here as well. So many more tools that you can find in that link. So last, I would like to talk about something that I think is useful for Fortran developers, and that is community and where to find more information. So first, I would like to talk about the Fortran Standards Committee. It may or may not be likely that any of you are interested in shaping the future of Fortran, but in the event that you are, as a member of the committee myself, I did just want to mention it and say that I'm a relatively new member of the committee myself. And so something that I am particularly working on at the moment with the committee is how we can make the process easier for new people that join the committee to be able to come up to speed with how it works and how we get new Fortran standards published. So we are working towards making it easier for new people to join and participate. So if you have interest, feel free to follow the links to find more information or contact me to hear about how you might get involved. I don't have time to talk any more specifically than that about the committee, but please do know that is available. What I would like to mention, though, is some upcoming features, because obviously a lot of this presentation was about features of Fortran. So it is important for me then to also highlight some upcoming features of Fortran that are not available now, but will be available in the future and that we do hope that you use someday in your code. So one huge feature set that is being added to the next standard of Fortran, which we are targeting 2028 for the release of the next standard. That is our plan. So one huge feature set that will be added is generic programming, so templates. Now, the templates in Fortran will be type safe because templates in Fortran are being designed with the idea of requirements and strong concepts in mind. And so this means that compilers will then be able to provide you actually useful, helpful error messages when you might encounter some bugs in your code involving templates. So look forward to that. Another thing that we have on our work list is asynchrony, so asynchronous tasks and asynchronous collectives, and then also a standardized Fortran preprocessor, which is great. I don't have time to get into why it's great, but it's great. And thank you to Dan Bonacera, who I believe is attending this call, who is a colleague of mine that is helping make this Fortran preprocessor be so useful. So lots of great work going on. But finally, I just wanted to note that as we started this talk talking about how there are some ideas out there about Fortran being dead or Fortran being antiquated, that I myself have found, and perhaps some of you in this audience have also found, that the people that continue to work in Fortran are often very passionate about their work and very passionate about the continuing existence of the language and how it still provides very useful things to the programming community in general, the HPC or the scientific programming community in particular. So yes, I have found that it is a vibrant, engaged developer community. If you'd like to engage with that community online, please do note some of these links. So fortranlang.org is a wonderful website, which has a lot of different things that can be very helpful. It has some tutorials of some more perhaps beginner or intermediary Fortran features and concepts. So it might not be useful to you, but do note that if you're working with a student who is new to Fortran, or if you're working with a collaborator from a different project or a different language background who now needs to engage with Fortran, those tutorials might be helpful for them, and then might help you because it might help lift the burden on you a little bit to get them up to speed with certain Fortran concepts. So do keep this website in mind. With those tutorials, it has links to interactive playgrounds where you can see those features that the tutorials are discussing in action. So that is pretty great. Fortran Lang also has a compilers page, which tries to give you an up-to-date, as much as it can, picture of what the Fortran compiler landscape is like. There's just in general some helpful language information and advice. It has a page about Fortran best practices, which can be helpful. It also has linked to LFortran, to a website where you can try using LFortran in your web browser. And LFortran is a Fortran compiler and interpreter that is in development. So that is very fun to play around with as well. And if you have questions, if you have a particular use case in your project that you're working with and you don't know exactly, you just need some additional help or advice on that particular use case, please do note that there is a Fortran discourse and it is very active and can be very, very helpful. So please do try posting there if you need to. And also, even if you don't have any questions, please do consider joining the Fortran discourse community and engaging, because you might be able to help answer questions that other people have, and you might be able to bring your own expertise and experience to the conversations that others are having on that platform. So please note that. And if you're ever curious about what the team at LBNL that is doing work related to Fortran, we do have a Fortran at LBNL page here, linked here, so you can always find more about that. And if you would like to email us, we have an email, fortran@lbl.gov. So if you'd like to contact myself or other members of that Fortran team at Berkeley Lab, please do feel free to email us there. And with that, I will say thank you and ask if there are any questions.
There was some discussion in the chat about how Julienne is actually vegetable tool based. Yeah.
Yes. Julienne is inspired by Veggies, which is a wonderful testing framework. And so I referred to Julienne as a lightweight testing framework. And I refer to that because Julienne provides sort of a subset of features that Veggies does. And that can be beneficial to have just a subset for a variety of reasons. But it also has added some additional features that work slightly different than Veggies. But yes, it is, in fact, based on Veggies. So great observation.
Yeah, I have a question. So I used Fortran with coarrays for a parallel algorithms course recently for master students. And first of all, I found it relatively hard to figure out myself which compiler needs which flags and which libraries to link. And I had to build the coarrays library. So my question there is, how do you see this in the future developing? Will it be easier to use coarrays and multi-image Fortran? How are the compiler vendors approaching this?
That is a great question. I don't know, in my discussions with different compiler teams, Fortran compiler teams, I don't know of any plans to sort of standardize the way in which coarrays can be used with compilers, whether you have to pass this flag or that flag, or use this library or that library. So I don't know that landscape is about to change significantly. But what I will say is that the parallel runtime interface for Fortran that I mentioned briefly earlier in this presentation, which was developed at Berkeley Lab, that is a compiler agnostic and runtime library agnostic interface that we are hoping, if people adapt that interface, we are hoping that could improve the compiler support out there for those features and could potentially help also the confusion that you might face when needing certain flags here or certain flags there. Although it doesn't necessarily, the PRIF interface doesn't require that the compiler, if a compiler uses that PRIF interface to support the parallel features, it doesn't require that certain flags are used to then take advantage of those features. So that might still differ from compiler to compiler, but we are hoping that this compiler agnostic and runtime library agnostic interface could make it so that more compilers could easily add compiler or add support for those features if they don't already have it. We're also hoping it makes it easier to switch from one compiler to be using a certain runtime library under the hood to provide support for the coarray features versus another runtime library, so that if you're targeting a particular architecture where a certain runtime library might perform better, then you can swap back and forth. So I have not seen a lot of movement recently, I will say, on compiler support for coarrays. Nothing significant. But over time, support in general, I do think gets better. And of course, as we all file compiler bugs, I think that is what we as the community can do to help compilers, is file really great compiler bugs when we encounter them. But I don't have a lot to speak to that in the future, other than I remain optimistic that people are interested in the PRIF interface and that hopefully that can add to the landscape of what's out there. Thank you for your question.
Yeah,
I hope that answers.
Yes, that was already great. But so the second thing we encountered was a significant performance bug, that if you did communication in one direction of a two-dimensional array, it would be 2 orders of magnitude slower than if you communicate in the other direction. And then it's kind of hard to figure out where to file my bug, because this was probably in the coarrays, the open coarrays library, but it might also again be related to how the compilers use it. So it's kind of, because it's a very scattered thing somehow, because it's, yeah.
That is a very good point. I would say that I would start by maybe filing a compiler bug with G-Fortran, and then maybe G-Fortran can indicate whether they think that it's an issue with their calling of the open coarrays library or with the open coarrays library itself. So I would probably start there, but it can be a complicated picture for the reasons that you stated.
I'll add a couple of comments there if that's okay.
Yeah,
Kate.
Please go ahead, Davian.
As I put in the chat, hopefully all compilers will eventually go the direction of the HPE Cray compiler, which is that they dropped the requirement for a special flag to use coarray features. And the NAG compiler has done that. And I think Intel is at least thinking about doing the same. So hopefully it'll get easier to use. And as far as performance goes, with open core arrays, the primary developer for open core arrays now is Andre Veriskild. He's in Germany, and he recently submitted a pull request that made some significant performance improvements with co-array communication. So I don't know if it'll help your specific case, but watch for that pull request to be merged and for a new release to come out.
There's a question in the chat also about GPUs. Will there be any change to the standard such that multiple copy in-out to GPU for offloading can be done prior to do-concurrent when multiple do-concurrents are involved?
Interesting. So if I understand your question correctly, I would say that that is probably not something that the standard would talk about. The Fortran standard doesn't discuss a lot about implementation details. So I think that if what you are asking is that if there's a particular feature, new feature that will provide that functionality for when there's multiple do concurrents involved, there are no such proposals on the table right now. But if the feature that I would need to look at this question and think about it more carefully later to see if it's something that would need to be added to the language or if that's more an implementation detail specific thing. But if it is something that could potentially be added to the language itself, I would say that there are certainly no proposals on the table at the moment, but could be in the future. There's always the chance that anything could be added to the language if proposals are put forth that the community agrees should be added. So potentially one could be involved in starting that process yourself. Who knows?
Okay, I have a question about FPM. For me, FPM, it looks like it's make on steroids, right? Make with make depend and really geared towards Fortran applications. What I ask myself is in this file, this configuration file you set up for the FPM for the build system, nothing is mentioned about which compiler is used, which options are used to compile the actual code. Where is that configured?
So FPM has some defaults. So what I think is true is that the default compiler that it will search for is gfortran and then GCC as the companion C compiler. And so because I was using those defaults values to compile the example that I had the screen video of, I didn't have to say anything about the compiler. I could completely remain silent on the subject and it would find those defaults and work without any problem. If you do want to use a specific Fortran and C compiler, you can of course specify that. So there are two options for that. Yes, there are two options for that. You can either set an environment variable. So I believe it is FPM _ FC or FPM _ CC, then for the C companion compiler. So if you set those environment variables, then FPM will use those compilers instead of the defaults. And then you can also, if you don't want to set those environment variables, you can also just pass a flag on the FPM line itself. So when you wanted to do FPM build, for example, you would just do FPM build -- I can't list the flag off the top of my head. I won't be able to spell it out for you exactly correctly, but there's a flag to specify the compiler. And what is fun about FPM is that you can do FPM build with one particular compiler, and in the build directory, it will have a build of all of those files used with that one compiler. If you then do FPM build with a different compiler, it's not going to go and overwrite the files that you just created with the previous compiler. It will then create a new subdirectory in the build directory. It will have all of those files. So you can go back and forth between using different compilers to compile your project, and you don't have to, throw away your build directory and get a new one. It will sort of sandbag those things separately, which can be useful.
Another question about good communication, the Ford tool. For me, this is like Doxygen. I know Doxygen,
yes.
Right? It's multi-language. I think it supports Fortran too. I guess Ford just does a better job with Fortran.
Yeah, so I know that Doxygen in the past has had some issues with Fortran projects. I do believe that it might have gotten better more recently. I don't know exactly the timeline of when those changes happened, but if you are using Doxygen for a Fortran project now and it's working great, then that's great. But Ford might not necessarily gain you anything if you already have Doxygen that is meeting all of your Fortran needs. But I do think that there are some particular cases where it might have problems with certain source code in Fortran projects it might have issues with. So if you are finding issues with Doxygen and your Fortran projects, then please do note that Ford is another option that could perhaps fix those issues because it is designed specifically with the Fortran language in mind. Yeah, it could address those things better.
Comment by Larissa in the chat. Doxygen has problems with OOP features, but Ford works well. Okay.
Okay, yeah. I've used Doxygen myself with C projects, but I haven't tried to use Doxygen with Fortran, so I didn't know off the top of my head what those features were, but I have heard about them. So yeah, that makes sense with my memory as well. So thank you for that comment.